is my computer system that I built. So I'm just going to zoom in real quick. This is the implementation screen. I've written it for the Nexus for FPGA. Utilization is around 8% of the lookup table, about 90% of the of this field here. I forget what it stood for. And what I have here is the actual output screen of the FPGA. So what I'm actually doing is I'm using this particular button here as the clock. This is my reset signal. Get a focus. And then I have this as a switch to be able to turn on the 100 megahertz clock that'll drive the processor. So I'm going to flip it, and you'll see what is your name. And then from here, I can type in on the keyboard like anything. So let's say let's go testing. Okay. And then if I press enter, it'll say, hello, testing. Nice to meet you. Do that again. Okay. And then I can then do like Khalil. And press enter. Hello, Khalil. Nice to meet you. So that's pretty much the system at work. The more interesting part is the fact that I can still reset it. Now I can step through the program. Actually, let me reset this again. And here we have the PC and everything else set initialized to 0. As I press the button, we'll go to PC4. That'll be the instruction that I want to go to. You see the control bus, the data bus, the values can be written into the register. The register address I'm going to write to. Values can be written to that register, as well as outputs from the ALU and the other registers in the MIPS. Oh, so I know this is a MIPS processor that I have developed. So you can keep incrementing through the program counter, and you'll see as I step through, it'll type out what is your name. So I'm just going to flip the switch again. Then I can type in whatever. So just what. Oh, let me backspace a little bit. Whatever. Also, there's protection for going too far back, and there's also protection for going too far in. There's a limit. So I'm going to hold down the backspace. Okay, and I'm just going to go. Oops, it isn't. Whatever. Enter. And see that working now. So just to show you, I'm just going to show you the assembly that was written for this. It's all done in MIPS. So we have just a couple functions here. A couple macros for pushing and popping to the stack. A main that will then will set up the stack, the stack register, stack pointer, as well as storing basically a 0 to the VGA position, and then it just writes the prompt, reads from the keyboard, then puts the rest of the text onto the screen. We have a function for puts. We have another function for putting a single character. Also handles backspace and left keys. We also have an area where we do fgets, which is just being able to grab and pull the hardware location or pull the keyboard for a key. And then we have the areas for the data. So this is just the stuff initialized inside of RAM. This is the memory location for the VGA address, and this is the memory location for the keyboard and for its ready signal. These are actually don't really mean anything. These are just here when I'm doing testing on assembly. But these get cleared out to, these end up just being the value that you get from the data bus after you select the device. So yeah, that's a system that I came up with, and this should be a really useful debugger. Oh, cool thing is that the areas up here, all this is all hardware controlled. So even though the processor isn't running, or it's stuck at 44 because I'm just jumping back to that same location, you can see that the values up there are still changing. These are the different scan codes for the keyboard. So 1C is A, and then B in this case is 32. And this is all driven by hardware, so the VGA terminal will rewrite the section of the screen over and over again. So even if you attempted to write to these locations, you could write to these locations here, but these locations here are going to be overwritten by hardware. So that's kind of what I built.